The injected toxin first spreads into a small area of the muscle, which depends on the volume injected. More volume gives more spread. After injection, the molecules of toxin Dysport diffuses into the muscle junctions, binding to receptors. If a high concentration of toxin is injected, then diffusion will be over a wide area, increasing the fields of effect. The active molecules are initially protected in the product veil by other proteins of so-called neurotoxin-toxin complex. There are several of these other proteins associated with the active neurotoxin. After injection, under the physiological conditions in the muscle, these protecting proteins fall away from the active neurotoxin and the complex completely disintegrates, freeing the naked neurotoxin molecules to act. The neurotoxin is composed of a heavy chain, which is a binder and a transporter, and a light chain, which is the highly potent active part. The neurotoxin molecules bind to the receptors on the outside of the neuromuscular junction. The binding is exceptionally strong and happens through two proteins on the surface of the junction. Once bound, the toxin cannot be removed. After binding, the toxin molecules is taken up into the junction through another sphere that is formed from the neuromuscular junction membrane. This sphere may be in fact an empty vesicle. Once in a new vesicle, the neurotoxin molecule then needs to get to the target site of action. A part of the heavy chain binds to the inside of the vesicle and actively acts to transport the light chain across and into the junction interior. Part of the heavy chain now acts as the chaperone for the light chain, the active part of the neurotoxin, as it unfolds and crosses the vesicle membrane. The light chain active part of the neurotoxin is then free in the neuromuscular junction to act. The active light chain approaches the proteins which are part of the normal synaptic vesicle binding apparatus for docking and fusion. The Dysport type A neurotoxin targets SNAP25 and actively cuts part of this protein, destroying the shape and structure, producing damaged protein on the membrane surface inside the junction. The neuromuscular junction has then been poisoned by the neurotoxin and cannot act functionally, which relieves the muscular spasm. The original nerve axon forms new sprouts after the main junction is poisoned, and this is believed to play some role in recovery of the normal activity.